applicable. We'll try to see how many we can cover today. We want to define, we want to start from the historical background of this concept. Data mining has got some background, which you may term them as historical. And when you look at them, most of them are inclined to statistics. When you look at them, they are inclined to statistics and the new computational methods. So when you look at the history, we are told that this concept was introduced in 1990. And some techniques were being used are techniques that we also see them in statistics. Some of them I'll have to share. When you look at their structure, what we call investigation, we look at it as if it is a concept that is purely applying some automated mechanisms or techniques to go through big volumes of data with an intention of revealing the insights that data could be having, and those insights should be converted into knowledge that we can use to make any kind of viable decision depending on which area of business are you carrying out your data mining process, or what objectives you have in mind when you decided that you want to carry out data mining. So when you look at the origins, let us look at the origins. The origins of data mining, number one of the origins is statistics, and here we apply statistics approach. When we look at statistics, we consider them to be the basis of most technology on which data mining is made, like regression analysis, standard distribution, standard variance, cluster analysis, confidence intervals. All these we apply them in data mining. And when you look at them, these are statistical approaches when you're carrying out data mining. Now, when you look at the form of statistical theory, which supports models of data and methods for prediction, however, we call them classical statistical models are much applicable. Another area we may look at when you're looking at the origin of data mining, we consider artificial intelligence approach, despite the fact that we may think that AI is a concept that just came this year or last year. This concept has been there, but on a low scale, and most of the systems, most of the ideas that this concept has ever been used to work are much of, we call them generative, not deeper. We normally call it weak AI or general AI. General AI is where we have devices that we make them have some basics of artificial intelligence, but they cannot be as intelligent as human beings. But we normally just borrow just an area, one line, and create a system that may work partially like a human being. We call them weak, general, and most of them are just generative kind of AI. So AI has been there, where we have got scientific artificial intelligence concepts which have been adopted by some high commercial business companies. So some business like Amazon, they're trying to embrace this technology, and they're also trying to embrace it both for their normal productivity as well as for mining of data or data analysis. So we have artificial intelligence forming an origin of data mining. And you'll see that for tools that apply AI, they do better than tools that don't do AI when it comes to big data mining and analysis. We also have got an origin of data mining, and this origin is based on machine learning. Machine learning and AI, they go hand in hand. In machine learning, where you subject objects to learn from environment, and from that environment, which has got data, you make them use the same data to behave or respond based on your requirements. So machine learning is a concept, and also it forms basis or origin of data mining. The fourth origin is database. This one we're borrowing from computer science or information technology. Database oriented approaches whereby the development of data warehouses and online application processing tools, OLAPs, for the analysis of big databases have also encouraged the arising of methods that we use to mine data or to mine knowledge from data, this big data. So when you talk about data warehouse, it's simply a big repository of data, but which has been classified. This one is a kind of data storage that all the data put in it have got their own structured and organized labeling than the big data. So data warehousing or data warehouses are being created on the basis of database. So for you to have a data warehouse, then you must have a number of database. And this database, you'll find that when it comes to data warehouse and you label each database based on the content that it has, then we convert that database labeling, which is a component of data warehouse, and give it a name called data mart. So in data mining, this concept is key, is important. Data base. So we look at the origins, we look at where we've come from in the context of data mining, and we realize that we have got number one, a statistical approach. It forms origin of data mining. Number two, we've got artificial intelligence approach, which forms origin of data mining. Reason, we are trying to borrow tools which are intelligent in a way to assist or to be able to make us achieve our data mining objective efficiently and effectively. Number three, we've got the machine learning approach, where we subject some intelligent objects to an environment of data and make them analyze the data and make use of this data to respond to the demands or requirements of that environment according to the user of that kind of a system. Number 4, we have got database. Database, which is, in other words, we call it data-oriented approaches. And here we mean data warehouse. Data warehouse is a large deposit of data which has got labels. And these labels are put in what we call data mats, meaning when you label each section based on the type of content that the data has, we call it data mat. So we've got those origins, 4 origins. Let us look at the basic concepts. Basic concepts in data mining. Basic concepts in data mining. When you look at data mining, and I'm actually talking about item number 2 on the board, you're able to see basic concepts and terminologies in data mining. And when we start talking about data mining, we cannot miss to mention data. We cannot miss to mention data. Number 2, we cannot miss to mention patterns, what you call data patterns. Number 3, we cannot miss to mention in our discussion data model. We cannot also miss to mention in our discussion business intelligence. We can also not miss to talk about big data, which is core when it comes to data mining. Data mining is not achievable in the absence of big data. So it is very core. We can also not miss to talk about data warehouse, something I've just mentioned. The other thing we cannot also miss to talk about, we call them data mining tools. In data warehouse, we cannot miss to talk about online application processing, which is a tool applicable in data mining. We cannot also miss to talk about data store in the context of data warehouse, data mart in the context of data warehouse. We can also not miss to talk about data sets in the context of data mining. So I want just to go through them very fast. We start with the terminology. The first one is data. Let us define data. What is data? Data is a very common terminology. Sometimes we could be defining the right way. Sometimes the books are defining right way or not the right way until you analyze the definition and see the gaps. Data is simply referring to raw facts. Raw facts is a combination of anything that is in a format that it cannot be used to serve and enable somebody make a decision. So data, in some text, they refer to them as figures. Some refer to them as numbers. But generally, we just know these are facts because even figures could be facts that can be used when you process them. So these are raw facts, which are not meaningful and useful in any format to the user. That is data. When you talk about data, you may classify data into various classification because data is general, but we may decide when you're carrying out data mining to be very specific. The data that you want to mine based on the nature and the collection approach of the big data that you are mining data from. We've got data classified as text. Data has to be classified as text. Has to be classified as text and numbers, which involves letters, worksheets, that is Excel and Microsoft Word or word processing applications. If we want to mine data which is related to those applications, then we'll be mining data in form of text. We may also want to mine data in form of images. With a reason, we want to mine photos. We want to mine pictures. If that is what we want to mine, we refer to that class of data as images or pictures. You may also want to mine data as graphics. Graphics is a class of data that may include content such as drawings, maps. If that is what you want to mine, then you're mining data as graphics. We may also want to mine data as audio, or in other words, sound. If this is the case, then we want to mine data that is in form of either speech, conversation, or even music, something that can be heard because it is mined, yes. Using the modern tools, we can mine them, but it depends what objective, because you cannot just commit resources on mining sound with no specific objective or something beneficial that you're going to gain, which is a class of data. And this one involves some moving pictures that you may want to mine with reasons. And I think this one may apply mostly maybe security oriented organizations, even speech. You may want to mine data, you want to collect what speak and see the patterns that can guide you and get the insight and use those patterns, formulate a model, and make use of that model to decide or effect a certain we call it a certain action. So we've got data classified in 5 different classes, that is text and numbers, images, which are pictures, graphics, which are drawings and maps, audio, which is speech, music, and anything which is sound, which you can hear, and video, which has got sound and pictures that are movable. And this is actually, most of them are captured on real-time occasion. Then you can store them. And when you want to mine them, you must have a specific objective that you want to achieve. The other one, we may ask ourselves, what is big data, especially in the context of data science, of data mining? Big data is defined as a large and more complex data repository which may be achieved from either new data sources that, if well sifted, and analyzed, then we can use the insight to address business problems. If you want to address a business problem, maybe, and you feel that, yes, this business has collected enormous amount of data, putting maybe one of the servers, then you feel that this information, if well sifted through, then analyzed, we are able to get patterns, then models that, if well applied, something beneficial may work. Meaning, we may either use it to reduce the cost of production, we may use it um, to reduce complaints from clients, meaning we are trying to reinforce customer satisfaction. And in business, customer satisfaction is a factor that allows the company to lock their customers to their services and products. And if that is the case, then the business is sustainable because you have enough clients that are making the business to run. No one is dropping because of one reason or the other. So we may use uh, data mining as a way of getting the insight, analyzing it, that is having patterns, models, then knowledge, then use that knowledge to perfect a certain area of concern in business. We have got another terminology we call data pattern. Not just a pattern, but actually, this one is specific. Data pattern. So data pattern is simply a set of data that follows a recognizable format from which analysis can be done to find what that data is talking about. So patterns can give us what information or what insight does the big data has. In most cases, data patterns are good when displayed using graphical display. That is, you can view, you can observe, and observation, you are able to assimilate and be able to understand that kind of information and then make use of it. Another terminology that is also good to know in data mining is a terminology called data model. Patterns create a model. So what is a model? A model refers to a visual representation of data elements. Visual representation of data elements which have got some connectivity. These elements are connected, and actually these elements is the pattern. So a model is a collection of patterns. And patterns exist, and the existent has a pointer or connected one to the other to form a particular pattern, a particular flow. And that flow is able to give an insight or the right indicator of what the big data has in relation to the business operations. So in other words, a data model Data model can also be an abstract model, which can organize elements of data and also standardizes that those elements, showing how they relate to one another. Those are patterns. Another terminology is business intelligence. Business intelligence is also key, and actually we achieve business intelligence also through data mining. We also do it BI. Business intelligence refers to real-time, relevant, actionable information or facts that can enable organizations or companies to make better decisions, which include taking informed actions and also implementing more efficient business processes. So business intelligence is a kind of information, is a kind of insight that we may achieve through data mining. This this information is very, very strategic. So business intelligence is one of the strategic information that most companies use as a weapon to outwit the competitors if they want to. They use that information, which is not an information that is exposed to any other person in the company. It is only exposed to strategic management who uses this information for strategic actions, strategic applications. So it's very important to understand business intelligence, and we can achieve this if we have big data, we mine it, then we filter, then what we get as knowledge, we look at it and see whether it qualifies to be strategic. And if it is strategic, then we call it as business intelligence. In most companies, business intelligence requires good resources. For you to achieve, you need to go further, either in terms of resources, in terms of finances, in terms of tools, in terms of storage. You need to have resources, good resources to achieve business intelligence. Another terminology that we cannot avoid, and this one also narrows within the big data, which I may also repeat so that we can see how we can apply them. That terminology like velocity, variety, which is normally applied on big data, volume, big data. Already we know that big data is a large, diverse set of information which are structured or unstructured that have grown to the rates that are so enormous. But this information can be used to change the operations of a company to better, for sustainability, for growth. So we have got velocity, mostly applicable on the term big data. And let me start with volume, not velocity. Let me start with volume. Volume on big data means high volumes of data which have got low density and also are unstructured. They don't have a specific format. They're so unstructured that it needs high level of technology to structure them when mining so that you get the right output. Velocity is simply the speed at which data is received and acted upon. The speed at which we can do the mining, get that information, and react. Variety is another term applicable on big data, which means many types of data available in that repository. Another terminology we cannot miss to talk about is what we call noisy data. Noisy data in data mining, what is it? Noisy data in data mining is simply some kind of distorted data that we get in data repository, that is big data. You will find that it might have been deposited there, but some either was not complete or it was complete, but due to a number of factors, some of the elements within the data are deleted, are altered, are modified, or are actually omitted. So sometimes you want to read the name when it is stored in the database during storage. Maybe the name was reading Jacobson, but you find that with time, that name Jacobson, it's missing B. So you don't know whether it is Jackson, or it's ambiguous because B is not there. So you need to find a way to fill. Otherwise, you fill the wrong character there. You miss the meaning of that when you're processing it. So now this one, when you talk about noisy data in data mining, before you mine, it must be curated. It must be corrected. Those are normally removed before you take it further for analysis and processing. So it's very important to avoid noisy data because this is a kind of meaningless, distorted, incomplete data that has been stored in the database, in actually the big data database, that in case you use it, you may not get, or you may make the wrong decision. You may not get the right patterns, and those wrong patterns may lead you to making wrong decisions, which may have negative impact. We also talk about data warehouse. Data warehouse is a terminology that we also need to understand. Data warehouse can be defined as a centralized collection of data and information which has been extracted operational sources and external sources of a company. So we can put our data in a central place, but in a somehow organized manner. Though it can still qualify to be big data if it requires some mining, because I know you can arrange some data, but still when you go to look at this data, it's not giving you an opportunity to analyze it, an opportunity to form models or patterns from it. So you need to use techniques that this data to have a positive impact to the business. So data warehouse is a centralized collection or a centralized repository of data and information, which has been extracted from the operational sources and external sources of a company. Meaning we may have data from within the company, we have deposited somewhere. Then we can also have information that we were getting from outside entities. We are getting from other companies. We are getting them from our alliances. We are getting them even from our competitors. Then put them somewhere in a centralized repository. If that is the case, we have created a data warehouse. Another terminology that we may also not ignore when we talk about data warehouse, there's a terminology we call enterprise data warehouse, operational data store, data mart, then you can ask, what are these? In the context of data warehouse, when you talk about enterprise data warehouse, it is simply a centralized warehouse of an organization, a centralized warehouse or a centralized repository of data of a company, a business company. We call it enterprise data warehouse. For example, a company like Coca-Cola. Coca-Cola is an enterprise, is a company that is creating soft drinks, and if it decides to centralize their data coming from external operations and internal operations, then it will be referred to as enterprise warehouse, because information that it has, it is all about revenue generation. Revenue generation. An enterprise is actually a venture that is aimed to create wealth. So if that is the case, the information you'll find in this data is nothing else, is issues of revenue, profits, revenue collection, profits, or even losses. Another term is operational store. Operational data store, in the context of data warehouse, is also, in other words, called in short, some books may use some short form. ODS is simply a data store which is required when neither data house nor the systems, that is the systems that operate on this system, support organization reporting needs. So operational data store, which is also called ODS, is nothing but data store that is required when neither data warehouse nor online transaction processing systems support organizations reporting needs. We call it operational data store. Another term is data mart. We call it data mart. Data mart, as I said, these are partitions. When you partition your data warehouse, those partitions you put in your data warehouse are called data marts. And every partition must have their respective data. They must have their respective content. And that partition is not nothing but trying to align every data to belong to a specific partition. If it is matters finance, there should be a data mart for finances. If is matters marketing, there should be a data mart for marketing content. If it is about administration, there should be a data mart labeled administration. So a data mart is a section or a partition within a data warehouse. We call them just a subset of a data warehouse. Another item, another word that we also understand, still when we talk about data warehouse, is data set, which is also commonly used in our data mining concept. Data set. What is a data set? A data set is simply a collection of data. When you put data in sets, in groupings, in some formatted kind of arrangements, then you form data set. These are portions. You put data in portions. And the reason we put them, maybe for easy analysis, for easy mining, etc. We can also say that simply an organized collection of data, an organized collection of data set. Another terminology still under data warehouse is metadata. Metadata, METADATA, metadata. In most data warehouses, you cannot miss metadata. It must be there because It is a kind of information that describes the information that exists in a data warehouse. Metadata. Metadata is data that describes and contextualizes other data within the data warehouse. It provides information about the content, the format, the structure, and even the characteristics of data that has been stored in a data warehouse. So it's also very important. It's actually a description of the data, what they are, which format are they in, the nature, etc. Another term we cannot avoid is normally, most of the time they use abbreviation, which is online analytical processing technology. Online analytical processing technology, which is abbreviated as OLAP, OLAP. OLAP is a technology which is a kind of software tool applied to analyze business data from different points of view. You get the data, then you use this tool to put data in different views so that you can understand or get the right insight in that data. We use online analytical processing, online analytical processing technology or processing software. We cannot miss to have this when we're also doing data mining, and also when we have a data warehouse, we cannot miss to have this. And when you talk about OLAP, it has got, we talk about the forms of OLAP. We have another one we call it relational OLAP, which normally I do as rollup. We've got we've got MOLAP, which stands for multi-dimensional OLAP model. We got HOLAP, which is hybrid online analytical processing, etc. We also look at data mining as a terminology. What is data mining? And we define data mining as a process of analyzing enormous amount of data or enormous amount of data sets in order to extract or mine useful intelligence from this data that will help the company to solve problems, predict trends, mitigate risks, and also find new opportunities of business. So we use data mining as a very, very important process, which companies, if well deployed and apply, may be able to analyze large amount of data for useful intelligence. And you remember we talked about business intelligence, which will enable them solve the problems that could be existing problems. A number of them could be maybe entropy problems, meaning a company is going to fall, a company is going to collapse, is a problem. So what do we do? Could be problems of customer dissatisfaction, could be problems of customers moving away from a company to other companies, could be a problem of your products, your stores not being your stores not being how can I put it? Your stores overstaying. For example, you buy goods, a stock, which you estimate in 3 months, you must have sold them, get your profits, get your sales, get your revenues, and restock. You find that that doesn't happen. It affects company. You have estimated that it should take 3 months, but it happens to take 1 year. That is a very big problem that you need to find out what could be the reason. Data mining is a solution to that. So in short, we may say that data mining is a process of analyzing large amount of data to get the insights or intelligence that may enable companies make rational or excellent decisions. So I think that is it for terminologies. That is it for terminologies. Then you may ask, why data mining? Why? Why data mining? Actually, yes, is a concept that came up, but why? Why are we having data mining? That's a question somebody may ask you as a data scientist. But if somebody asks you, may just respond by saying, data mining is crucial, is a crucial component of successful analytics initiatives in organizations. Why are they successful analytic initiatives? Because they're able to make information generation, which can be used in business intelligence. And you remember I mentioned or I explained what business intelligence is. So data mining, the intention, in most cases, the intention is to get some business intelligence. And as I've said, business intelligence is part of the strategic information of a company, information that can make them gain a competitive advantage, information that can make them be sustained, information that can make them grow, meaning your company will grow by reinvestment, either in terms of capital or in terms of openings. You extend your company beyond a certain confined region or town. If you extend it to other towns, you are making a growth, and this growth might have been the might have come from the existence of data mining processes. Yes, Stacy.
Hello, sir. I was asking, is it possible for us to see what you're explaining? It will be easier for us to understand more. Maybe if there are
That is
notes or write ups that you have
the notes.
that,
You'll read them.
yeah,
I'm
like
just
whatever
explaining,
you're
then you'll read
talking.
because
Uh huh.
uh, I'm applying the teacher
Uh huh.
methodology. If I
Oh.
bring the notes, then you go through them on the board. Is like I'm teaching a primary school student how to read draw notes.
Mm.
You get the point, Stacy.
Yeah, yeah. Sorry, I
I'm
get
just
it.
explaining what I'll share for you to read on your own.
Okay.
I'm just opening out. Just when you get
Okay.
it, you remember the lecturer was able to mention it.
Okay. Okay.
Yes.
Okay.
So
Thank
what
you.
I'm discussing here, I'll be able to give you some handouts. Is that okay, or you still persist? I can still share, but it's a very wrong method of teaching university students. If there's any lecturer who's using that methodology, is using the wrong method in teaching. Sometimes you're told, Stacy, sit down. I'm in class, even physical class. I don't give you notes. We read the notes from because there's lecturers who print notes and give students, they go through them. You read as we explain. It doesn't work like that. You either give, we call them, discuss them, then you share your notes. Either they can write, you can tell them write, but I'm trying to reduce the problem on your side by writing, because for other groups, they write notes. I don't give them handouts. I teach them how to use the system. And when you talk about sorry, my Wi-Fi had lost actually. I was wondering. So, um, using my using my slide, which is PowerPoint, I was discussing. I think I was on data mining. I want to look at the data mining process using the 4 stages. Um, when you want to do data mining, you can use 4 stages, and also you can use 6 steps. These are 2 different terminologies. Stages and steps are different. Steps can be formed in a stage. But here I want to look at the 2 so that we can mark the difference when you're told to use stages and when you're told to use steps. Data mining process, using those stages, we have got stage number 1, which is data gathering. And this one may involve you collect the relevant data for analytics and application. And this collection, they say, before you collect, you must identify, meaning identify where this data is coming from, which sources, which systems, data warehouse are they coming from. So the first thing, data gathering, you ensure that you know where this data is coming from, data sources, because various sources can be used to bring in data. As I said, you can have external sources or internal sources. When the internal sources, which databases within the company do you want to use as the source of data to your system? Then when you talk about data warehouses, if you have data warehouses or a data warehouse, yes, which data warehouse are you using as a source of data for your data mining? Stage number 1. Stage number 2 is data preparation. When you want to data mine, you are supposed to start with data exploration. You profile the data, then you pre-process. Pre-processing is one of the methods that we use to cure, to remove what we think is not right, what we think is repetitive. you remove it, you curate it. Then after curating, that is, you cure it, you clean it, cleansing. You cleanse it, meaning you're removing errors. Then after that, you ensure that you have also sorted out some what we call data quality issues. Number three, after you've done all that, then mine your data. That is, when the data is prepared, that is, it has been pre-processed, then a data scientist has to choose one, the appropriate mining technique, and we'll see them. There are a number of them. And in the selection of mining technique, you must also be able to look at the kind of algorithm. We also look at what is algorithm in data mining, technique and algorithm that is applicable to the kind of data that you've collected, and also to the kind of data mining objective that you have in mind. So you should be very, very, very careful. Number four, you need to do analysis. Then after analysis, you do interpretation. You analyze data. After mining, you look at the results, and after looking at the results, which must have what you call analytical, they must be in form of analytical models. And these models should be able to help you make a decision, should be able to help you to make a decision and any other business actions that are viable based on the objective of mining that data. So those are the four stages of data mining. When we want to talk about six stages, six steps, no, sorry, when you want to use the six steps are: number one, you must understand the business, or you must understand the situation of the company. You must understand the company, which ones data to be mined. And if that's the case, when you understand the situation, meaning you're understanding the problem at hand. Understanding the situation, in other words, is simply understanding the problem that the company that requires data mining has, which you think, or they think, if we data mine, that problem will be solved. That is number one. In the same time, you must also talk about the objectives. The situation, then, what will be the objectives of mining and finding the solution to the current situation the company is facing? Number two, you understand the data. And here, this number two step, understanding the data, means you need to figure out what kind of data is needed to solve the issue at hand, and then collect it from the proper sources. First of all, this is the problem, but not every data will solve this problem. There must be a specific kind of data. So which data can I get and use it to solve the issue at hand? That is number two. Number three, prepare the data then. When you are preparing the data, it means you But
the network is not so good.
look at some of the problems of omission, the problems of noisy data. When you're preparing data, you'll be able to tell data is noisy. And my network, yes, there's a challenge with the network or what?
Yeah, your network is not so good.
I didn't know that because let me see what to do. It's good to raise your concern actually. If you are not, because I may not know whether I'm speaking to myself because of the network or not. You are actually the receiver, the consumer. When we are not communicating from my end, I must communicate for the class to run well. So make sure you raise the concern. Anybody the same problem like Stacy? Or Stacy is maybe your network that is not good. Maybe
No,
yours or mine. It is mine. Eh?
good.
If it is mine,
Okay.
it's good you've mentioned. Let me see whether the Wi-Fi that I'm using has issues so that I use a different technology. Because if you're not getting me, then the class is not running as required. So let me see what to do. Let me just give me a minute. I do some corrections to my network connections. Now, I've changed my location. I don't know whether you can get.
Yeah, it's okay now.
Okay. I was talking about the 6 stages, the 6 steps, not stages, the 6 steps that you can apply when carrying out data mining. I was on step number 3, which is talking about preparing the data. And I had mentioned that when you get data from big data repository, it does not mean that every data that you get there is accurate, is complete. You'll find that there's data which is noisy, incomplete, meaningless, inaccurate, with omissions. Now, you need to prepare this data. You need to find out a way by making it the omissions to be filled with the correct content. Don't just fill it for the purpose of filling the space, because the chances you may fill it with the wrong replacement, the wrong fillings, which at the end of it you may not get the right insight. So it's very important that when you are doing this, be very, very careful. If, as I mentioned, if you had in the data warehouse or big data, you're able to find the word like stainless stainless plate, stainless plate, then you find that maybe that word stainless is missing N, or is missing I, or is missing A and I. This meaning you cannot spell it well. Don't know. When you remove A and I from the word stainless, it's very hard to reconstruct. You're not very careful, and you may decide to reconstruct it, meaning you want to cure it or prepare it. Then you put the wrong characters. When you get the output, you find that the output you're getting is not what was to be achieved, because when you are curing this data, you cure it using the wrong curation. So it's very important. Step number 3, to prepare. Step number 4 is about modeling. This step number 4 is about modeling, meaning you are trying to employ a technique together with an algorithm that will be able to extract or ascertain the patterns you'll get. And as I've said, a model is a composition of patterns. So you'll have to come up with patterns, ascertain patterns as a scientist. Then after getting the patterns, you'll have to test and evaluate that model. When you test and evaluate the model to see whether it is satisfying, that is step number 5, then you can decide on how effective the result delivered by a particular model will help the company meet the problem or the objective which was intended for data mining. Number 6, the last step is deploying the solution. When you get your solution, which you have ascertained that it is now ready to be applied, then deploy it. Deploy that solution to solve the problem that you were able to discover before you started doing data mining. So when we talk about the 6 stages, which I will also share a graphical representation, we normally have 2 of them that will will give us the structure of the 6. That is, we call it the cycle of the 6 steps applied in data mining. After talking about the 6 steps and the 4 stages, let me talk about types. In data mining, we have got majorly and commonly applicable 2 types of data mining. The first one being predictive data mining and descriptive data mining. In these types of data mining, you will find that we are trying to even employ some statistical techniques. For example, when I do a predictive data mining, I'm using the type of data mining we call predictive. Then it may involve the process of classification. I may decide to do it using classification. I may decide to use regression. I may decide to use prediction. And also, I may also even decide to use time series analysis, predictive. In descriptive, I may decide to use clustering. I may decide to use summarization. I may also decide to use what you call association rules. That is about relationships. I may also decide to use what you call sequence analysis. So when we talk about these two types, predictive, then the techniques you can employ in predictive, I may repeat them. One, you can use prediction technique, or you can use regression technique or classification technique. When we talk about descriptive, you can decide to use clustering, you can decide to use associational rules, or you can decide to use sequence analysis or sequence discovery. So in a nutshell, descriptive data mining, which is the first one in the types, is a kind of mining approach applied in order to provide descriptive information from the data elements. And what I mean by descriptive information is simply some special characteristics of that. So it's trying to narrow your data mining approach to get special characteristics of the data elements that may end up forming what we call the patterns, which will be collected as a model. When we talk about predictive, if it's predictive, you mean you are trying to assess the history of data elements. Predictive is, first of all, assess the history of data elements or a situation from the data being mined. After you've assessed, try to find out the patterns, then observe these patterns. Then you may decide to allow that information to be used for whatever reasons that your intentions were. And this intention will be an intention that is focusing on future trends, predictive. You're trying to focus on future trends in the data. So those are the two common methods, types, sorry. Those are two types of data mining applicable. Descriptive and then predictive. So what I may just also say that when you talk about predictive, then the models you normally get in predictive are predictive models. The models you normally get in descriptive are descriptive models. Models that are able to ascertain certain or special characteristics on data, and these characteristics will be able to be represented as patterns within a model. So those are the two. In data mining, apart from the types, apart from the steps, apart from the stages, we have got tasks that cannot miss to occur in data mining tasks specifically. And some of these tasks could be also be converted into techniques. So not converted. Some of these tasks are being aligned to some techniques. For example, some data mining tasks may include data characterization. Data characterization, which is trying to have description of the general characteristics of objects, general, in the target class of data. Number two, the result from data characterization, or what you call the result from characterization and discrimination data mining task, characterization and discrimination data mining task. The result from this process or this task can be represented in form of bar charts, maps, curves, and even pie charts. When you talk about number two, we have got prediction. Prediction is a task, and this task is actually meant to detect the inaccessible data whereby the prediction task will apply regression analysis in order to detect the missing numeric values in the data. And this is a method used to ensure that whatever that is going to come, the result, is not faulty, but is relevant for business intelligence. So prediction is common. Prediction is common when detecting inaccessible data, inaccessible data, which may be required for you to detect the missing numeric or the missing values of data in order to ascertain the future trend of that data. Number three is classification. You are able to find that classification. We found it to be a technique in predictive type of data mining, but here also we are talking that we are actually considering to be a task. And the task that we use to create data structures. We create data structures using this method. The other one is association analysis. We also saw it in our predictive method, our predictive method of data mining. We saw association analysis, and this actually is the link between, is actually ascertaining the link between the data and the rules that bind them. So you want to discover, one, the data, then if they're connected, do they have any connection? And if they're connected, what are the rules? What rules are making this data to be connected? If the attributes, for example, if it's because of the similarities, is it because of the nature? So association analysis is first of all to find out the legal. So I think I should mute. So that confusion of noise. Then we look at the outlier. Outlier is also used in statistics and is used to establish data components. We want to establish data components that cannot be clustered into any given class. We use outlier analysis, cluster analysis. Clustering task involves the arrangement of data in groups. Put your data in groups, then you've clustered. It's not necessary to look at the similarities of the characteristics, which is not like classification. Then we have evolution. We have what we call evolution and deviation analysis, which we say that is a task carried out to uncover patterns and shifts in actions over time. So those are the tasks we can carry out. The last item I also want to talk about is importance of data mining in business. We've got several areas that will make data mining important, because we cannot just say data mining is important without having empirical evidence, that is, without having a proof. So data mining is important. And why is it important? One, we want to establish where we can use to justify the importance of data. We have got data mining in business activities. If that is the case, if I'm using that as a case to justify that data mining is important, then when we go to businesses in general, data mining in business involves analysis of historical business activities stored as static data in a data warehouse or databases. And the goal is to reveal the hidden patterns and trends. If we're revealing hidden patterns and trends when you're doing data mining on business activities, we are able to make decisions. And if that is the case, these decisions are based on the trends and patterns which have been hidden in the data warehouse or the big data repository. To do this, most of the time, we must use software. It cannot be done manually. So data mining, we have to use tools to achieve the right goal. In business, why do we data mine? In some business, why do we data mine? This may include trying to perform market analysis. And this may include when you want to sell products, you want to identify new products and how you can bundle them. We want to find the root cause of manufacturing problems. We want to prevent customer attrition, or we want to acquire new customers. We do data mining in business for a number of reasons. And the major ones I've mentioned, one could be if actually it's a selling kind of company. We give services or products, and by selling them, then we may want to do market analysis. We may also want to find out the root cause of problems we experience in manufacturing or in production. We may also want to find out the reasons why customers are not happy with us. we may also want to do it because we want to acquire new customers. We want to move to extend our customer base. So we want to acquire new customers and make more revenue. The other thing could be we want to retain the existing customers by profiling them. Number two, apart from these businesses, the general businesses, the other areas we can use to justify data mining to be important is supermarkets and in superstores. In supermarkets, you'll agree that even now, when you go to most of the supermarkets, when you go by, you can have you can be like 1,000 customers. Each customer is holding about 6 items. When you move to the checkout section, nobody is not keen even to know what you've bought. What they're only after is for them to just pass the item on the barcode reader. Then when the barcode reader detects the product so that it is checked and priced, then you pay for it, you move out with the item, you'll find that nobody at the end of the day will even go to the server to check, indeed, since morning, what items have we sold? Apart from them just calculating how much have we collected. You'll find that when they do their stock, they're not keen on what items are we've sold. They're keen on what amount of money have we made from the product that we've sold. So if that is the case, supermarkets is a very prime area for you to carry out data mining. And I'm very sure if you go there, you do your data mining, you are able to reveal things like you can even find out that there are products which, when they are bought, they support the buying of others. For example, I'm buying sugar, and if I'm buying sugar, I cannot just buy sugar. I should actually buy sugar and milk, or sugar and bread, or sugar and tea leaves. So you'll find that there's a trend that a customer who had bought sugar also had milk or tea leaves. Milk or tea leaves. So if that is the case, you need to find out if they go, then when you're stocking, make sure that when you have sugar stocked, make sure also tea leaves are well stocked. Otherwise, a customer will come, will find sugar and find the tea leaf not stocked well. Then they buy your product, sugar here, meaning they're going to buy the tea leaves from another supermarket, giving them a challenge. And if they go to the supermarket, they find that the tea leaves and the sugar could be there, and even the way to reach them, they're closer to each other, then they move away from a supermarket. So supermarkets is also another prime area to do what we call data mining. The other area is in actually banks. Not only banks, the use of debit cards. We normally use debit cards for maybe fueling your vehicles, for doing some shopping. Debit cards are used to carry out transactions. And even you and me, you'll find that when you use a credit card, take it to a supermarket or a fueling station, you just either slot it in the device to be detected and your amount is deducted from your account, or in a supermarket, the same is done. So nobody is even making a fallout how many credit cards are being applied to do purchases. Nobody is doing that analysis. Nobody's collecting that data. This data you have to collect, you can go to supermarkets, you can go to fueling stations and some of these shopping centers and find out how many transactions have been done to their systems using debit card. You can collect this data, then see whether is the debit card the best way to be used for making payments or not. You either use that or you decide people to be paying cash. The other area is customer relationship management. In companies, customer relationship management is another also prime area for data mining, which can detect, mine data, which can discover the satisfaction of our customers. It can give us the view, the insight on how our customers are satisfied with the products or services. And this one may make you, if they're not satisfied, you look for a solution. If they're satisfied, you see how to extend the customer base, how to extend the satisfaction to the customer so that they don't even think of moving away from your company. Yes, Syed Mali.
Thank you, Doctor. Just for clarity, does
Yes.
data mining involve the analysis of data to find insights, or it is just the extraction of data? Because I'm a little bit confused with the word mining being just
Uh-huh.
extraction, or does it also
You're a little bit
involve
confused.
analysis? Yeah.
Yes, when we'll be doing it, I think is topic number 9. You cannot just do data mining and leave it at that. So what was the intention? When you mine data, for example, you don't just mine data. Mining data, when you want to analyze data, first of all, you must mine it. So the major process, the key process in data mining, after you have extracted your data, is you want to analyze it. And analyzing, you're trying to find the insight. You are trying to find the hidden value information. So it has to be done together. So we move on. We also look at the human resource function. Data mining can also apply there. And the human resource, which may range from doing what you want to retain employees, you want to promote them, you want to find out about salary ranges, you want also to look at the benefits. So you can data mine, and the intention here to look at the trends, to look at the problems. And when you data mine, we'll be able to find out if there is anything that is bringing the morale of the people down, or you can be data mine so that you can just uplift the morale without even the complaint. You just look at it and see, no, this one we need to raise here so that our employees are motivated in a way, and motivation is equivalent to productivity. So motivation is also key. Human resource can use data mining, meaning you go into your records, you go into your employment records, you go into your employment manuals, you go into human resource manuals, and find out whether there is something you can improve. And that improvement means you must have, first of all, mined the data in that relation, then analyzed it, getting the insight. Then when you're trying to deploy or employ the solution, it does not backfire. It is actually hitting to the target of what the intention of the data mining was. Another one in what we call sales. You can do data mining in sales. Apart from supermarkets, you can also do some data mining in selling, and this may also bring in some information for efficient use of the capital to drive revenues, growth of the company, etc. We also do data mining in manufacturing, which is still in business, to find out how much costs on production. Are we making losses, or are we doing production? Are we doing production using more resources, which are not equivalent to the revenue that we collect. Another area we can do data mining, we can do data mining in facilities that allow us do transactions like money payments, M-Pesa. When we may want to determine whether the platform is fraud-free, we can use data mining tools and they can tell us the rate of fraud that is carried on a certain platform of payment. Even in banks, they do data mining to discover how many fraud incidents we were able to get in this month, this year. And that one may give them an idea on how to protect, on how to avoid risks, on how to seal the vulnerable areas that fraudsters are using to penetrate into the system of payment transactions. So up to that point, let me get a question before I call it a class. But I'm going to share the content, what we've discussed today. I'm going to share through the email that I was given by the class rep. So let me stop at that point. In our next discussion, we'll be discussing data mining system, the architecture of this system. So I'm stopping here, but let me get questions. And number two, I want to mark the register. I want to find out. And actually marking means on the chart, place your student number and your name so that I'll use that as a record of your presence in this class. Otherwise, I'm stopping at this point. So you can place your name, your student number, then you leave the class until we meet next week.